Hi there, today we are going to learn about the intersection of planes in 3 dimensions. However, we will only focus on how 3 planes intersecting with each other without parallel to each other. There are 3 ways planes can intersect with each other, which are intersecting pairwise, intersecting in a line, and intersecting at a point. In order to check whether the planes are intersecting in which way, we can do the volume test, which is using this formula: n1 dot product, n2 cross product, n3. The reason why we use this formula is to determine whether the normal vector of the planes are coplanar or not. Therefore, if the volume test equal to 0, it means the normal vectors of the planes are coplanar and the planes are either intersecting pairwise or in a line. On the other hand, if the volume test does not equal to 0, it means the normal vector of the planes are not coplanar and the planes are intersecting at a point. In the next few slides, I will show you how to determine which way do the planes intersect and how to solve the question. Over here, we have 3 scalar equations of a plane. To look for the normal vector of this plane, we simply just have to take the number in front of the 3 variables. Next, we take the normal vector to do the volume test. While doing the volume test, we first have to do the cross product to look for another vectors and dot product next. Since the volume test does not equal to 0, it means that the planes intersect at a point. To know exactly at which point, we have to work with pairs of equations to eliminate one of the variables. For this example, we'll eliminate y variables. First, we take the first equation and multiply it with 4. Take that minus with the second equation. And for the result, we'll name it as the fourth equation. After that, take the first equation and multiply it with 2. Add it up with the third equation, and this will be the fifth equation. After we get the fourth and fifth equation, eliminate another variable. Since x variable is already the same, we'll eliminate it by subtracting the fourth and fifth equation. Now we have already solved for z. Substitute it in either fourth or fifth equation to solve for x. Here we'll substitute it in fourth equation. After we get x, we can now substitute both x and z into one of the equations to solve for y. In the end, we can know the point which the 3 planes are intersecting is 3, -5, 1. Now, for the next example, repeat the volume test by taking the normal vector from the 3 scalar equation to determine whether the normal vectors are coplanar. Since the volume test is equal to 0, the planes are either intersecting in a line or intersecting pairwise. After that, work with pairs of equations to eliminate one of the variables. We will first add the first and second equation to eliminate z variables. The result of it will be the fourth equation. Next, multiply the third equation by 2 and subtract it with the first equation. And here we have the fifth equation. Divide the fourth equation by 2 and the fifth equation by 15. After that, make y variables the subject and we can see that it is a true statement since the left side is equal to the right side. Since it is a true statement, it means the 3 planes intersecting in a line. To solve for the line, we have to determine the parametric equation of the line. Therefore, let x a parameter. Substitute x into equation 4 and let y be the subject. Now, substitute x and y into equation 1 and make z the subject. After having 3 parametric equations, change them into vector equation. The final answer will be x, y, z equal to 0, 2, 10 plus t, 1, -1, -3.